Hello everyone. Today we are diving into how to solve binomial coefficient series, and by the end of this video you will have a clear understanding of how to solve them. So let's get started. First of all, let's see the basics, which is what is NCR. So this is the formula of NCR: n factorial divided by n minus r factorial into r factorial. Now these are some important properties that you must know in order to solve series questions. So this is the first property. We can write NCR as NC n minus R. Second is this one. We can write NCR as n by R and reduce the superscript and subscript by 1. The third property is this one, where we can add two NCRs into a single term. The condition is that the superscript should be same and there should be difference of 1 in the subscript. The third property is NCR divided by NCR minus 1. Here also the superscript is same and the denominator is 1 less than the numerator part, and this is equal to n minus r plus 1 by r. Now let's see some questions based on these properties. So this is the first question. I would urge you to solve it yourself and then see the solution. So in this question we can see it is a summation series, and uh, the first term is equal to 1. Now for the summation we have this property NCR plus NCR plus 1 equal to n plus 1 CR plus 1. But the condition for this property is that the superscript should be same, but here all of them are different. So to solve this problem, what we can do is 1 can be written as m plus 1 cm plus 1. Now we have this and this is same, so we can add them and write it as m plus 2 cm plus 1. Now these two are same, so we can write it as m plus 3 cm plus 1, and so on till we reach the end last term, and after adding this it will become m plus k plus 1 c m plus 1. So this is the answer. Now this is the second question. Here you can see that we are using division, and hence we can use the second property, which is this one. Now let's see how we can solve it. So whenever you are solving any series question, you should always try to write this series in summation form. So so first let's see what will be the general term of this series. So it will be r c r divided by cr minus 1. Now it is a summation of this, where r is from 1 to n. Now as you can see, this forms the property which is n minus r plus 1 by r. So this is equal to summation r into n minus r plus 1 divided by r. Now this cancels out and is equal to summation n plus 1 minus r. Now we can split the summation and it will be equal to summation n plus 1 minus summation r, and this is 1 to n. Now adding n plus 1 n times will give us n into n plus 1, and minus this is 1 to n. Now this is what 1 plus 2 plus so on till n, and this is the sum of first in natural numbers, which is n into n plus 1 by 2. So this is n into n plus 1 by 2. Now finally the result we get is n into n plus 1 by 2. So this is how you can solve some basic series questions based on NCR properties. Now let's derive some basic results that we will use further to solve some more complex questions. So to derive them, there's some expansion that you must know, which is 1 plus x raised to the power n is nc0 plus nc1 times x plus nc2 x square plus nc3 x cube and so on ncn x to the power n. Now if we put x equal to 1 in this expansion, then what we get is nc0 plus nc1 plus so on till ncn is equal to 1 plus 1 to the power n. So this is the first result that we can get. Now we can put here minus 1. So if putting x equal to minus 1, what we get is nc0 plus nc1 plus minus nc1 plus nc2 minus nc3 and so on till minus 1 to the power n ncn. This is equal to 0. Now this is another result. Also what we can see from this is that sum of even binomial coefficients like nc0 plus nc2 plus nc4 so on is equal to the odd coefficients nc1 plus nc3 and so on. Now this is the result, and using this result in the first result, what we can get is let's say the even part is x, so the odd part will also be x. So we are calling this as x. So the this sum is what 2x, and this is equal to 2 to the power n, which implies x equals 2 to the power n minus 1. Now from here what we see is c0 plus c2 plus c4 and so on till c even the last term is equal to 2 to the power n minus 1, and it is equal to c1 plus c3 and so on. So this is the another result that we get from them. Now let me write down all the results we have derived so far. The first result is summation ncr from 0 to n is 2 to the power n. Second result is summation 0 to n minus 1 to the power r ncr is equal to 0, and this also implies c0 plus c2 plus c4 and so on equals c1 plus c3 c5 and so on, which is equal to 2 to the power n minus 1. Right, so these are the results we have derived so far. Now what are the other results that we need are summation r and cr from 0 to n. This is equal to n into 2 to the power n minus 1. Now try to prove it yourself using this property, this result and the NCR properties. Okay, so now let me solve it. Summation 0 to n r and c r. Now we can write it as summation 0 to n r into n by r n minus 1 c r minus 1. This cancels out and we can take this n out of the summation. This will become n summation n minus 1 c r minus 1. This is what? 2 to the power n minus 1. Thus we get the result n into 2 to the power n minus 1. Alright, so this was the third important result we need. Then the next result is summation r square ncr 0 to n. Now this is also similar to prove. Try it yourself, then I will show it to you. So let's start. This will become 0 to n r square into n by r n minus 1 c r minus 1. This cancels out. Now it becomes 0 to n will come out and r n minus 1 c r minus 1. Now this now this is similar to r and cr summation, but here this and this should be exactly same, so we can make it exactly same by writing it as r minus 1 plus 1. Then we can distribute this over both of them, then it will become summation 0 to n r minus 1 n minus 1 c r minus 1 plus n minus 1 c r minus 1. Now this is the result and this is also a result, hence we get n into 2 to the power n minus 1 into n minus 1 plus this will become 2 to the power n minus 1. Sorry, this will be n minus 2, right? Because the result was this is equal to n into 2 to the power n minus 1. So you have to subtract 1 from this. So this will be n minus 2. Now we can take n minus 2 as common out. N into 2 to the power n minus 2 into this will be n minus 1 plus 2. So the final result is n into n plus 1 into 2 to the power n minus 2. Now let's see all the results we have derived. So these are all the results that we will need to solve the questions. Also, these are the two results that I have written, which I have not derived, but they are fairly easy to derive. Now all the questions that you will encounter in binomial coefficient series can be divided into 5 or 6 types. So let me tell you all of them. So this is the type 1 where some constants are multiplied. Now the constants will have some special property. They will be a part of some series. Like for example, here it is an AP with common difference of 4, right? Also, this may not be an AP, but some expression, some series that can be written in polynomial form. So for all these type of question, you need to write the general term and then use the above results. So the general term for this will be 4r. Now putting r equal to 1, we get 4, but we need is 3, so minus 1. This into ncr. This is the general term. Now this is the summation form for this complete series from 1 to n. Now we can easily split it. Summation 4r ncr minus ncr. This is equal to 4 summation r ncr minus summation ncr. Now This is the result, n into 2 to the power n minus 1, and this is what, 2 to the power n. Thus the final result is, we can also put this in power, so this will be n into 2 to the power n plus 1 minus 2 to the power n, which is equal to 2 to the power n into 2n minus 1. Now this is the second question. Try to solve it yourself. It is also fairly easy. So now let me solve it. So writing the general term for this, here also this is 2, 5, 8. So this has a common difference of 3, but with power of 2. So this can be written as 3r minus 1 squared c. Okay, for this we need, okay, we will put 2, so we will get 6, and we want is 2, so this will be minus 4 cr, and this is summation from 2 to n. Now we can open this. This will be 9r square plus 16 minus 24r into ncr summation. Now just open this and put the values. So this was type 1. Now let's see type 2 questions. So these are the type of questions where some constants are divided, and to solve such questions we need to use this property, which is, it can, like we have seen it earlier, this is ncr equal to n by r n minus 1 c r minus 1. Just we have changed the left hand side to right hand side. So this is the first question, and firstly we need to write it general term. So that will be cr by r plus 1 into r plus 2 and a summation from r equal to 0 to n. Now we will use this property and combine this denominator into the NCR part. But for that we need a n plus 1 in the numerator. So we will multiply and divide it. N plus 1 divided by n plus 1. Now after this we will need n plus 2. So we will multiply and divide it. Now these are constants and we can put it out of the summation, and we will combine this part. So after combining it 2 times we will get 1 by n plus 1 into n plus 2 into summation 0 to n plus 2c r plus 2. Now here it may look like that you can use the result directly, but because of the limits we cannot use it directly, because when we will open this summation it will be n plus 2 c2 plus n plus 2 c3 and so on up to n plus 2 c n plus 2. Now for the result we also need n plus 2 c1 and n plus 2 c0, but these both are missing, so we will add it and subtract it. Minus n plus 2 c0 n plus 2 c1. Now for this we will use the result, which is 2 to the power n plus 2, and this is what, n plus, sorry, this is 1 and this is n plus 2. Now we can just write all of them. This will be 1 divided by n plus 1 into n plus 2 into, this is what, 2 to the power n plus 2 minus 1 minus n plus 2. Now we can solve it. This will be minus n and minus 3. Let me just write it here, minus n minus 3. So this is the final result. Alright, now let's see the last question for this type. So here I have directly written it in summation form. We can just solve it. So again we need to do the same thing, but we cannot directly use the property because we also need r plus 1. So for that we will initially multiply and divide by r plus 1, then we can do that. So we will write it as summation 0 to n ncr by r plus 1 into r plus 2 into r plus 1. So this we have multiply and divide again into n plus 1, n plus 2 divided by n plus 1, n plus 2. Now this is equal to, let me just erase this. So this will be, we can just combine this all and this thing. So this will be n plus 2 cr plus 2 into r plus 1 summation n1 divided by n plus 1 into n plus 2, and limits are from 0 to n. Then this will be, now here we can see it that we can use r and cr summation this result, but we need to first make it because here it is r plus 2, here it is r plus 1. So we can write it 1 by this n2 summation r plus 2 minus 1 n plus 2c r plus 2. This will be equal to summation r plus 2 n plus 2c r plus 2 minus summation n plus 2c r plus 2, 0 to n, and this also 0 to n, and 1 by these products. Now this part we have already solved in the previous question, so you can use the result, and this we will now see. Now opening this we will get 2 n plus 2 cr plus, sorry, n plus 2 c2 plus 3 n plus 2 c3 and so on, n plus 2 n plus 2c n plus 2. But to use the property we also need n plus 2 c1 to 1 and 0, so we can ignore this, but this is something we are missing, so we will add it and subtract it, minus n plus 2 c1. Now for this complete part we can use the result, and this is a constant which is n plus 2. Right, so here you can just put the values and write the complete result. Now it comes the third type, which is when binomial coefficients are multiplied with some another binomial coefficient. For example, here we have the power of binomial coefficients. So to solve such question we need to smartly choose some two two expansions and multiply the required terms. So here I have chosen 1 plus x raised to the power n, and another is x plus 1 raised to the power n. The condition is that in one expression the x should be in increasing power and in another it should be decreasing, so that when we will multiply the terms we get a constant power of x. Right, so now here we need is nc0 squared, nc1 squared, so this is also squared, so we can just multiply these terms, this term, and what we will get is c0 square plus c1 square plus c2 square and so on cn squared, and all will have the power of x as n. Now if you will multiply this complete expression and this complete expression, you can see that you can get power of x to the power n only when this is multiplied with this is multiplied with this, and so on, because if you multiply this with any other power, it will either be less or more. Hence we can conclude that when we will multiply these two, which will be 1 plus x raised to the power 2n, and if we find the coefficient of x to the power n, it will be this term. So what we all need to do is just find the coefficient of x raised to the power n in this expression, and coefficient of x to the power n in 1 plus x raised to the power 2n is simply 2ncn. So this is the final answer for this question. Now this is the second example. You can try it yourself, then I will solve it. So now let's start. This example is also same as the previous one, and we need the same expansions, and I have already written them. Let me just expand them. Alright, so now in this example also what we need is c0 c1. So you can multiply c0 c1 c1 c2 and then so on till n minus 1 into cn, and here we will need x to the power n minus 1, coefficient of x to the power n minus 1 in 1 plus x raised to the power 2n, and that will be 2nc n minus 1. Now this is the third question, and this is also exactly same, you can solve it. But now let me tell you another way to solve it using permutation and combinations. So let me just write it in a different form. So I'm writing it c0 cn minus 3 using ncr equal to nc n minus r plus c1 cn minus 4 plus c2 cn minus 5 and so on till cn minus 3 c0. Now why I have written it like this is so that the sum of both of them becomes constant, which is n minus 3 in every case, right? So now what I'm doing is, let's say we have two sets where we have n boys and n girls, and we want to form a team of a team of, sorry, 2n n minus 3 students. Now to form a team of n minus 3 students using n boys and n girls, how many ways are there? So there are 2n cn minus 3 ways, choosing n minus 3 students from total 2n students, as there is no restriction on what will be the composition of the team, right? Now another way of writing this is, we will choose 0 boys and n minus 3 girls, or we can choose 1 boy and minus 4 girls, or we can choose so on till n minus 3 boys and no girl. Now this is the expression we want to find the answer to, and this is equal to this expression. Now let's see the next question. Alright, so now you can try this question yourself, and then I will solve it. Okay, so now let me solve it. Now here we need some constant into NCR squared. So one expression we can use this one, c0 plus c1x plus c2x square and so on till Cn x raised to the power n. Now in the another expression we want the coefficient these numbers to be there. Now how we can get this? So as you can see here, the power is a number that we require in the front. For C2 we need 2, which is the power of x. So we can use differentiation here. If we will differentiate this expression, we will get n into 1 plus x raised to the power n minus 1, and this will be equal to 0 plus c1 plus 2 c2x plus so on n cn x raised to the power n minus 1. Right, now one thing we are missing is that we need decreasing power of x here, as we already have increasing power of x. So we can either change this to x plus 1 and change this, or we can, one another method of reversing a series is putting x equal to x 1 by x. So let's try this method. As this you can try yourself. Now putting x equal to 1 by x here, we will get n into 1, sorry, 1 plus x to the power, sorry, n into 1 plus 1 by x raised to the power n minus 1. This will be equal to c1 plus 2 c2 by x plus so on n cn by x raised to the power n minus 1. Now let's take the LCM. So this will be n into x plus 1 raised to the power n minus 1 divided by x raised to the power n minus 1. This, now let's also take it there and multiply it. So this will be removed from here, and this will be c1 into x raised to the power n minus 1 plus 2c2 x raised to the power n minus 2 and so on till n cn. Now this is the final series that we will use using this and this series, right? So here what we can do is we need c1 into 1c1, c2 into 2c2 and cn into ncn. Now after multiplying that, we will get n into 1 plus x raised to the power 2n minus 1 equal to the required term and x raised to the power n minus 1. Thus we require coefficient of x raised to the power n minus 1 in n into 1 plus x raised to the power 2n minus 1, and that will be equal to 2n minus 1 c n minus 1 and this n. So this is the final answer. Now this is the this is the fifth question, and here you can see that there is a power on the coefficient also. So I hope you have already understood which series we will use. The one we have derived here, this one, 2 times. So this will be n into x plus 1 raised to the power n minus 1 equal to c1 x raised to the power n minus 1 plus 2c2 n minus 2 and so on and cn. The other series will be n into 1 plus x raised to the power n minus 1. This will be the one we found here, which is c1 plus 2c2 x and so on up to n cn x raised to the power n minus 1. Now again just multiply them, this into this into this and this. Now what will we will get is n square into 1 plus x raised to the power 2n minus 2 equal to c1 square, 2 square, c2 square, and so on into x raised to the power n minus 1. Now we need coefficient of x raised to the power n minus 1 in n square 1 plus x raised to the power 2n minus 2. Right there, and that will be n square 2n minus 2 c n minus 1. Now let's try to find this result without using this method and instead use the type one we tried. Now this we can write it as summation r square cr square, and this will be equal to summation r square into, we can take out n by r from both the NCRs, so this will be n by r into n by r and cr minus 1 n minus 1 square. Now this cancels out. This will be equal to n square summation n minus 1 c r minus 1 squared. Now what will be the value of this? We have already solved. Let's see that. The value will be 2n cn. So now let's just put it here. This is equal to 2n minus 2 c n minus 1 into n square. The same result we have derived using the type 1 we have learned. Similarly, you can derive this result also using the same method we have just discussed. Right now, this is the type 4. What this type says is that if we put r to n minus 1, n minus r in the summation series, then the series will be reversed. And if we add the reversed series to the original expression, then the series can be simplified. So in this question, let's see, s is this summation and s2 is this summation, and we want to find the relation between them. Now let me open this summation. So this will be 0 by nc0 plus 1 by nc1 plus 2 by nc2 until n by ncn. And let me just put r to n minus r, n minus r c nc n minus r. Now this is what ncr only, so write ncr 0 to n. Now this is, after opening this expression, this will be n by ncr plus n minus 1 by nc, sorry, not r, n 0 0 0. Then this will be n minus 1 c 1 plus so on till 1 divided by nc n minus 1 plus 0. Now as you can see, the series is exactly reversed. This term is same as this term, this is same as the previous one, this is same as this one, this is 0 only. Let me just remove it, and this is 0. Right, so you can see the series gets reversed when we put r to n minus r. Now let's add the reverse series to s2. So s2 is equal to summation 0 to n r by ncr. Now s2 also equal to summation 0 to n minus r by ncr. Right, now let us add them. So this will be 2s2 is equal to summation, the denominator is same, so we can add the numerator, so this will be n by ncr. Now as you can see, we made a constant here, so we can put it out to summation, so this will be n summation 1 by ncr. Now this is s1, right? Let me just erase it. So this is S1. So finally what we get is 2S2 is equal to n times S1. S2 is equal to n by 2 times S1. So this is the relation. And now this is the second example. Try it to solve yourself, then we will solve it. Alright, so now let me solve it. Again, what we need to do is, in such questions, as we can see, n minus putting r to n minus r will reverse the series. So just put it. So this will be summation nc n minus r sine n minus r into x cos n minus r times x. This will be equal to summation ncr sine n minus r times x cos rx. So let's call it s. This is also s. Now we will add them. So 2s equal to summation ncr into sine rx cos n minus rx plus sine n minus rx cos rx. Now I hope you can observe this is the summation formula for in trigonometry, and 2s equals summation ncr sine rx plus n minus rx, and this is equal to summation ncr sine nx. Now this is constant, so 2s equals sine nx summation ncr. Now this is 2 to the power n, and s equals 2 to the power n minus 1 sine nx. So as you can see, this was also pretty simple question. Now let's move to our final type. So this is type 5, where we are having changing superscripts. As you can see here, initially this is 2n, then 2n minus 1, 2n minus 2, and so on till n. So here the superscripts are also changing. Now the observation in this kind of question is that it is a binomial expansion inside a binomial expansion. Let's understand this by example. So this is the example where we have nc0, 2ncn, nc1, 2n minus 1cn, nc2, 2n minus 2cn, and so on till n terms. Now what you can observe here is, if we ignore the second terms, then this is essentially nc0 minus nc1 plus nc2 and so on. Now you have seen this expression already. This is 1 minus x raised to the power n, right? The expansion of this gives the coefficients as these. But now we are having another term multiplied where the superscripts are changing. But as you can see, the subscripts are constant. They are always in, right? So what this means is that this is x raised to the power n, the coefficient of x raised to the power n in some other binomial expansion. So for example, 2ncn can be coefficient of x raised to the power n in 1 plus x raised to the power 2n. 2n minus 1 cn is coefficient of x raised to the power n in 1 plus x raised to the power 2n minus 1, and so on, all of them, right? So what we can say is, this is the overall expression 1 minus x, but in this 1 minus x, the x is varying again and again, right? So what we can write, this is nc0 into, let's change this with this expression. So this is 1 plus x raised to the power 2n minus nc1 into 1 plus x raised to the power 2n minus 1 plus nc2 into 1 plus x raised to the power 2n minus 2, and so on. Now what we need is coefficient of x raised to the power n of this term to get this complete term, coefficient of x raised to the power in this term to get this complete term, and so on. So what we can finally say is we need coefficient of x raised to the power n in this complete expression to find this result. Now we can make this as a binomial expansion, but to make it binomial expansion completely, we need this power to be consistent with our expansion. As here we have n, so this means this will be something raised to the power n. Hence, the power should be less than n always. It should be n, n minus 1, 2 n, n minus 1, n minus 2, and so on. But we have an extra factor of n everywhere. So we can take this 1 plus x to the power n common out. So we can take this 1 plus x to the power n common out, and this will be nc0 into 1 plus x to the power n minus nc1, 1 plus x to the power n minus 1, and so on. Now this forms the complete binomial expansion of 1 plus x to the power n into 1, sorry, this is decreasing in power, so the first term will be 1 plus x raised 1 plus x minus 1 raised to the power n, right? So this will be 1 plus x raised to the power n into x raised to the power n. Now the coefficient of x raised to the power n in this is equal to constant term of 1 plus x raised to the power n, and the constant term is 1, right? And the nc0 part, that is the constant value. So 1 is the answer to this question. Now this is the last question, and again we can what we can see is the this part is same as the binomial expansion of 1 plus x raised to 1 minus x raised to the power n, and this is something another binomial expansion. So what we can write this is as nc0 into, this seems like a binomial expansion of 1 plus x raised to the power 2n, this as 1 plus x raised to the power 2n minus 2, and same here also we have constant subscripts, so this means that we need the coefficient of x raised to the power n in all of them. So by the above logic, again we can say this is nc0 into 1 plus x raised to the power 2n minus nc1 into 1 plus x raised to the power 2n minus 2, and so on, and we need coefficient of x raised to the power n in this. Now this is nc, sorry, again now here what we need is the power should be either increasing or decreasing, and what we need is they should be continuous, but here we have difference of 2 in all of them, and also they all are even, so we can take 2 common out. This is n minus 1 into 2, right? All of them will have 2 common out. Now what we need in power is something raised to the power n, something raised to the power n minus 1, and so on. So we can put this 2 inside. So this will be nc0 into 1 plus x squared to the power n minus nc1 into 1 plus x squared to the power n minus 1, and so on. Now this is a binomial expansion, and this will be, here also we have decreasing power, so this will be 1 plus x squared minus 1 raised to the power n, and we need coefficient of x to the power n in this. Now this is equal to 1 plus x square plus 2x minus 1 raised to the power n. Right, now this will cancel out, and this will be x into x plus 2 raised to the power n. This is x to the power n into x plus 2 to the power n. Now we need coefficient in this, hence we need constant in x plus 2 raised to the power n, and the constant term will be nc0 into 2 to the power n x raised to the power 0. This will be the constant term, hence the answer is 2 raised to the power n. Now finally we have completed all the types of questions, and there will be hardly any question out of this all 5 types that we have seen till now. So thank you for seeing all these types and complete video. See you in the next one.